Hi everyone. Today we are going to discuss about electrostatics, the important relations and formulae regarding to electrostatics. This formula important for you for going competitive examination. The Coulomb's law is the first law of electrostatics. The Coulomb's law states that the force is directly proportional to product of the two charges Q1 and Q2 and inversely proportional to square of the distance between them. That is, F is proportional to Q1 by Q1 Q2 by d square. That is F equal to K into, if you remove the proportionality, Q1 Q2 by d square. The proportionality is given by 1 by 4 pi epsilon naught epsilon r, where epsilon naught is absolute permittivity or air permittivity, 8.854 into 10 power minus 12 farads per meter, whereas the epsilon r is relative permittivity for air equal to 1. It has no unit, air relative permittivity. For air gap, what is the important force? 9 into 10 power 9 Q1 Q2 by d square. That is for air gap. This formula is important. Competitive examinations, they will ask this formula, F equal to 9 into 10 power 9 Q1 Q2 by d square. Next, what is electric field intensity? Electric field intensity means it is force per unit charge is called electric field intensity, E equal to F by Q. You already know that a force equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 by d square. If one of the charge get cancelled, then Q by d square you will obtain. That is QE equal to 1 by 4 pi epsilon naught epsilon r Q by d square. Newtons per Coulomb, the unit of electric field intensity is. Electric field intensity at point P is given by, suppose the point P is considered at a point, the charge is located at somewhere, 1 by 4 pi epsilon naught epsilon r Q by r square, the distance between from the origin to at point P, that is Q by r square. E at surface is, at surface, if the surface the radius is r, then 1 by 4 pi epsilon naught epsilon r Q by r small r. We have to remember Q by r square and Q by r at surface at point P. Electric field inside is 0. That is very important. Electric field inside is 0. These three formulas important regarding competitive examination. Now electric field density, it is also called as charge density, D equal to Q by A. That is charge per unit area is called as electric field intensity. The unit of electric field intensity is Coulomb per meter square. Relation between electric field intensity and electric flux density, D equal to epsilon E, where epsilon equal to epsilon naught epsilon r. Therefore the relationship between electric field intensity and electric flux density is D equal to epsilon E. Potential, coming to potential, the potential, electric potential is given by work done per unit charge is called electric potential. Work done is force into distance divided by Q. Joules per coulomb or volt is the unit for potential. V equal to 1 by 4 pi epsilon naught epsilon r Q by d is the formula to calculate potential at a point P. V at a point P is given by 1 by 4 pi epsilon naught epsilon r Q by r. Suppose the point is on the radius, then Q by r, 1 by 4 pi epsilon naught epsilon r Q by r. V inside equal to V at surface equal to, both are same, voltage inside equal to V at surface, that is equal to 1 by 4 pi epsilon naught epsilon r Q by r. This is the V inside equal to V at surface. That is the important formula regarding electric potential. The relationship between electric field intensity and voltage. Relationship between electric field intensity and voltage is given by E equal to V by D, volts per meter. Capacitor. Everybody knows that capacitor C equal to Q by V or Q equal to CV. C equal to epsilon naught epsilon R A by D. C equal to parallel plate capacitor. Capacitance is given by epsilon naught epsilon A by D farad. Now capacitor works as open circuit for DC. Why it acts as open circuit for DC? The DC of frequency is 0, hence it acts as open circuit for DC, works as short circuit for AC. Battery charging is not possible in case of AC. Why it is not possible? Because of AC having alternating current, alternating cycle. During positive cycle the battery will charge, during negative cycle the battery will discharge. The net charge is equal to 0. Hence battery charging is not possible in case of AC. That is very important. What is the reason behind why the battery will not store AC? Now when combination of capacitors, when capacitors are connected in series, C equivalent 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. Parallel combination, when capacitors are connected in parallel, it is equivalent to series. When resistances are connected in series, R equivalent equal to R1 plus R2 plus R3. Similarly, for capacitors, when they are connected parallel, C equivalent equal to C1 plus C2 plus C3. Charging of a capacitor, it is very important. The charging of a capacitor voltage V equal to supply voltage V into 1 minus e power minus t by tau. That is current I equal to I into e power minus t by tau. Charge Q equal to Q into 1 minus e power minus t by tau, where tau is known as time constant. Time constant equal to RC. Whereas small voltage, the voltage across capacitor is 63.2% of V. This is very important. We have to remember 63.2 of V. If they given that 100 volts, then what is the voltage stored? Charging in a capacitor is 63.2% of voltage. Therefore time constant is 63.2% of full voltage. This formula is important. Time required for full charging of a capacitor is, what is the time required for full charging of a capacitor? Is 5 into time constant. 5 into time constant, that is the formula regarding full charging of a capacitor, time required. Let us see what is the graph regarding charging of a capacitor. If you take time on x-axis 0 to infinite, small v, I and q, then the graph will be like this. Already we discussed the charging voltage V equal to small v equal to V into 1 minus e power minus t by tau. I equal to, already previously we in the last slide, that is I equal to e power minus t by tau. This is the graph representing charging of a capacitor. Now how the capacitor will be discharged? Discharging of a capacitor. 1 minus if we remove, then that is the capacitor discharging. Charging of a capacitor is discharging of a capacitor is small v equal to discharging of a capacitor small v equal to supply voltage, applied voltage e power minus t by tau. We are removing 1 minus. Similarly, discharging current is given by total current or charging current I e power minus t by tau. This the graph also important. If you remember this graph, you can easily answer the questions in competitive examination as well as GATE. Everybody knows that energy stored in a capacitor is half CV square. That if you replace C equal to Q by V, then you will get 1 by 2 Q square by C. Next, what are the quantities SI units and quantity SI unit? Force unit is Newton. Electric field intensity unit is Newtons per Coulomb or volts per meter. Electric field density is Coulomb per meter square. Quantity and SI unit. Capacitor is Farad. Permittivity is farads per meter.